What's up, everybody? This tutorial is going to cover how to calculate power and beta using an example. So the power of a significance test, and then beta, which is the probability of a type 2 error. All right, so here's the example. So Cola Company claims that their bottles contain 300 milliliters. There is reason to believe that these bottles contain less than claimed. So this is the claim that we're going to be testing. And we're going to be testing it using the following hypotheses. So the null hypothesis is that mu is equal to 300. So that, if that ends up being true, it means they're filling bottles to what they claim to be filling them to. The alternate hypothesis is that mu is less than 300. So if there's evidence for the alternate hypothesis, that would suggest that the company is underfilling their bottles, which is what we want to test. All right, so now it says, suppose we're testing at the alpha equals 0.05 level. So we have a 5% level of significance. And the sample size is n equals 6. The population is assumed to be normal with sigma equals 3 milliliters. So the population standard deviation is 3. All right, now the question says if the null hypothesis is false and the true mean is actually 296, calculate power and beta. So in this case, we're going to be assuming the null is false and that the actual mean is 296, so that the company is actually underfilling their bottles. All right, so what we want to be doing is, again, calculating power and beta. So power is the probability of rejecting a false null, which is a good outcome. That's what I want to do. I want to reject a false null. So ultimately, I want the power to be high. Beta is the probability of failing to reject a false null, or the probability of a type 2 error. And I do want that number to be low. Okay, so let's learn how to calculate them. So what I'm going to do is I'm going to start with that assumed mean from our null hypothesis. So I'm going to assume that the mean is actually 300 as they claimed. I'm again working with a sample size of 6. My population standard deviation is 3, and I have an alpha value of 0.95. Okay, so what I need to do first is I need to calculate what I call a rejection value. So I want to figure out how big should my sample mean be, or where will that sample mean be between rejecting the null and failing to reject the null. So I want to figure out where is that cutoff point. And the cutoff point is related to my alpha value, so my alpha value of 0.05. So what I'm going to do is I'm going to start just by looking at the sampling distribution. So we know the population is normal, so that means the sampling distribution is also normal. This is a sampling distribution of x bar. And because sigma is known, I'm going to be using a z, or a normal distribution. I'm going to center that distribution at 300 with a z-score of 0. And what I'm going to count by on my axis is my standard error, so sigma sub x bar, which is the population standard deviation over the square root of n. So 3 over root 6, which is 1.225. Okay, so that's what I'm going to count by on my distribution. So this is going to be about 301.2, 302.4, 298.8, 297.6. Okay, and they'll have the corresponding z-scores. Okay, so that is my picture. So now what I want to do is figure out where am I going to reject and where am I going to fail to reject. And that's, again, going to happen at that 5%. So what I want to do is I want to separate. And again, because we're doing a lower-tailed test on this, I want to figure out where is the lowest 5%. Where does that separate the lowest 5% and the highest 95%? So it's going to be about here. So this region over here has that 0.5. And that's where I'm rejecting. So I need to figure out where is that cutoff point. Okay, so that can be done using the inverse norm calculator function. So on my TI calculator, I'm going to do inverse norm of 0.5. And if I do that, that's going to output a z-score of negative 1.645, which is probably a number you're used to using. So now what I want to do is I want to convert that back to an x bar value. So I do that by taking my mean of 300, subtracting that z-score times my standard error. Okay, and if I do that calculation, I end up with 297.99. Okay, so basically for any sample mean below 297.99, I'm going to reject my null hypothesis of mu equals 300. For anything higher than 297.99, I'm going to fail to reject the null. Okay, so just for simplicity, I'm just going to round this up to 298. So my rejection value is going to be at x bar equals 298 milliliters. Okay, so now that, again, is my rejection value. I'm going to reject for anything lower than that. And now I'm going to go back and use what's actually true about mu, so 296. So if I'm rejecting anything less than 298, rejecting the null for any x bar value less than 298, if my mean is actually 296, so then I want to figure out, well, when will I be able to reject that false null? When will I fail to reject? All right, so what I'm going to do next is I'm going to make a new picture, and I'm going to center it at that true mean now. So I'm going to center it at 296. So x bar and z are my two axes. Okay, and then I'm going to go ahead and count by my standard error. Okay, so setting up my picture. Okay, now what I'm going to do is I'm going to take that rejection value that I calculated here, the 298, I'm going to place that on my new picture. So 298 is going to be about here. Okay, so that's x bar equals 298. And then I'm going to split my picture into kind of two different sides here. So for this green region here, what I'm going to be doing is, this is where I reject. So reject the null. So I'm going to reject the null in that green region for any x bar value less than 298. I'm going to let's use pink then for the other side. That's over here. So the pink region now is where I am going to fail to reject the null. So that's over here. This is fail to reject the null. Okay, so now because I know that the null is false, anytime I reject the null, that's going to be in this green region. So this green probability now is what we call the power. So the green region is what we call the power of the test. This pink region here, right, is failing to reject a false null. So that's what a type 2 error is, and that's what we call beta. So beta, the probability of a type 2 error. Okay, so then all I have to do is calculate a z-score for 298 and then use normal CDF to calculate a probability. All right, so I'll do that first, or I'll do the z-score first. So it's 298 minus 296 over that same standard error. So this is going to be a z-score of 298 minus 296 over the standard error, 1.633. So that's that z-score. So then to calculate the power, right, I'm going to use normal CDF. Right, and the green region here is to the left, so I'm going to do 1e, or negative 1e99, comma, that z-score that I just calculated, 1.633. Okay, so I'll do that on my calculator, normal CDF. Okay, and this then gives me the power of 0.949. So almost a 95% chance of rejecting that false null. And again, we want the power to be high, so that's probably pretty good. Beta then, you could use normal CDF if you want, but beta will always be the complement of the power. So we can just do 1 minus the power, and that gives me 0.051. So those would be my two calculations here for power and beta. All right, so that is how you calculate power and beta. This specifically was for a z-test for mu. So yeah, that's it. Thanks for watching.